chapter, we already discussed the first part of thermodynamics, which consists of differentiating heat and temperature, as well as identifying these scales used in temperature, how to convert one scale to another scale, and also discuss the first effect of heat, which is the thermal expansion. So today, we continue with the different effects of heat, which begin with the change in temperature. So the change in temperature when an object is being exposed to heat, or when it absorbs heat or releases heat, then um, an absorb of heat or a release of heat may affect the movement of its atom. So when an object absorbs a heat, then the atom or the molecules of that object will move faster. And when the moment it releases heat, so its molecules or its atom will move slower. So um, therefore, uh, as the movement of the atom increases, so if bibilis yung movement ng atom ng isang object, then the temperature of the object will also increase. So since temperature is the average kinetic energy of the molecules, so as the molecules increases its movement, then the kinetic energy will also increase, and that's why the temperature of an object will also increase. So, and if the object, okay, if the molecules of the object um, moves lower, so kung mas mabagal yung movement ng atom or ng molecules ng isang object, then the kinetic energy of that object is also is it has a lower kinetic energy, which results to a lower temperature, because the movement of the atom or the movement of its molecules is directly related to the temperature of the object. Okay, so I repeat, if an object absorbs energy, then its molecules moves faster. Okay, so when heat energy is absorbed by a material, its molecules move faster. And when the molecules is faster, okay, if the molecules is faster, then therefore the kinetic energy produced by the molecules is also then the molecules may create a bigger or a larger kinetic energy. So, and if the kinetic energy is, if malaki yung kanyang kinetic energy na mabubuo, then mas malaki rin yung temperature ng isang bagay, since temperature is the average kinetic energy of an object. And if the object releases heat, then its molecules, okay, if dahan-dahang nirelease ng object yung kanyang heat, then yung kanyang molecules naman dahan-dahan ring babagal. And that is the reason why its temperature will decreases, okay? So bababa yung kanyang temperature since yung molecules niya is nag-move slower na siya. So therefore, yung kanyang kinetic energy is also decreasing. So an effect to the movement of the molecules of an object is also an effect to the movement to the temperature of the object. So the movement of molecules is directly related to the temperature of the object. So kung mas mataas yung kanyang movement, kung mas mabilis yung movement, then mas mataas rin yung kanyang temperature. And when the movement is slower, then mas maliit rin yung temperature ng isang object. So, in the change of temperature, okay, the change of temperature, we will use the equation for the specific heat. Okay, we will use the equation for the specific heat in identifying the heat energy absorbed or heat energy released by the object. But what is specific heat? So specific heat is the amount of energy needed to raise the temperature of a 1 kilogram substance by 1 degree Celsius. So that is the specific energy. And the equation for specific energy is H is equal to mass times specific energy, which is C times delta T, where H is the heat absorbed or released, which is in joule. M is the mass of the substance, which is in kilogram. C is the specific heat of the substance, which is in joule per kilogram degree Celsius. And delta T, which is the change in temperature, which is in degree Celsius. So using this equation, we can be able to identify the heat energy absorbed or the heat energy released by the object. Okay, but how can we, using this equation, how can we determine if the the object is absorbing heat energy or releasing heat energy? So to do that, by simply looking at this equation, we can be able to identify if the object is absorbing heat energy or it is releasing heat energy. But how can we do that? By looking at the value of our H. Okay, by looking at the value of our H, if our H, okay, using this equation, if our H or the heat transfer is positive, okay, if our H is positive, then it means it is absorbing energy. And when it is negative, then it is releasing energy. So, in short, if positive yung value ng ating H, then it is absorbing energy. When it is absorbing energy, then it is increasing ang kanyang temperature. But when it is negative, then it is releasing energy and nag-decrease yung kanyang temperature. So bumababa yung kanyang temperature when it is negative. Okay, by identifying this, we can be able to identify if the object is absorbing energy or releasing energy. Or we can just simply look at the temperature of our object if nag-increase or nag-decrease. So if nag-increase, yung kanyang temperature, then therefore it is absorbing energy. But if nag-decrease yung kanyang temperature, then it is releasing energy. So in short, siya yung nagbibigay ng heat energy. So using this, we can be able to identify absorbing or releasing heat energy. So let's try to use this equation in a given problem. Okay, so a 1,182 calories is needed to change the temperature of a 250.0 gram metal from 28.0 degrees Celsius to 50.0 degrees Celsius. So what is its specific heat? So in this case, we are looking for the value of the specific heat of a given metal which has heat transfer 1,182 calories. So since it is positive, then therefore we assume that this is absorbing energy. So since positive yung kanyang H or yung kanyang heat. So the mass of the metal is 250.0 grams, and its temperature rises from 28.0 degrees Celsius. So ito yung kanyang initial temperature to 50.0 temperature. So ito yung kanyang final temperature. Okay, so using this given, we can be able to solve for our specific heat using the equations H is equal to mass times specific heat times the change in temperature. Okay, but since our heat transfer is in joules, okay, so since yung SI unit ng ating C is in joules per kilogram degree Celsius, so first we need to convert our heat, which is in calories, to joules, and our mass, which is in gram, into kilogram. So convert natin first si calories into joules. So 1,182 times 4.186 joule divided by 1 calorie. So cancel yung calorie. So the result is 4,947.852 joules. So ito yung converted heat. And our mass, which is 250 grams, convert into kilogram. So cancel yung gram. And that is 0.25 kilogram. And for our change in temperature, simply subtract lang natin yung kanyang final minus initial. And that is 22 degrees Celsius. The next, substitute natin sa ating given equation. Okay. So after we substitute, simplify natin. So 25 times 22, that is 5.5 kilogram degree Celsius. So since yung hinahanap natin is si C, or the specific heat, divide natin both side by 5.5 para ang maiwan na lang ay si C. So 4,947.852 divided by 5.5, that is 899 joules per kilogram degree Celsius. So since the least number of significant figure we have is only 3, so we will round this to 3 significant figure. And that is, so since 900 is only one significant figure and 899.6 is 4 significant figure, so ang gawin natin, i-round natin ang ating 900 to convert natin si 900 to scientific notation para magiging 3 significant figure siya. So from 900, move natin 1 and 2, and that is 9.00 times 10 to the power of 2 joules per kilogram degree Celsius. And 9.00 times 10 to the power of 2 is now 3 significant figure. And that is the specific heat of the metal, which rises its temperature from 28 to 50 degree Celsius. Okay? So another example. Okay, so another example. A 240 joule object is needed to change the temperature using a specific heat of 0.0920 calories per grams degree Celsius from 28.0 degree Celsius to 50.0 degree Celsius. So what is the mass of the object? So ngayon, ang hinahanap na naman natin ngayon is si mass ng object. So kanina, we are solving for the specific heat. So this time, the specific heat is given, which is 0.0920 calorie per gram degree Celsius. So ito yung ating specific heat. And we also have the heat transfer, which is 240 joules. So ito yung ating heat absorbed. Then we are solving or looking for the value of the mass of the object. which has an initial temperature of 28.0 degrees Celsius. So ito yung kanyang initial temperature. And its final temperature is 50.0 degree Celsius. So using the equation H is equal to M times C times delta T. Okay. So before we can substitute our given, first, since the value or the unit of our heat transfer and the specific heat are different, okay, our heat absorbed is in joule and our specific heat is in calories per gram degree Celsius. So since magkaiba yung kanilang unit, so joule and calorie, so kailangan muna natin i-convert either of the two, either si 240 joule, convert natin to calories, or si 0.0920, convert natin to joule. So since mas madali na i-convert natin si 240 joule into calorie, so convert natin siya into calorie. So 240 joule, cancel yung joule, times 1 divided by 4.186, and that is 57.333 and so on calories. So magkapareho na sila ng unit ng ating specific heat. And then for our temperature, subtract lang natin, that is 22 degrees Celsius. So pwede na natin sila i-substitute. So cancel yung degree Celsius since magkapareho sila. Then multiply 920 times 22, and that is 2.024 calories per grams. So since yung hinahanap natin is si mass, so since mass yung hinahanap natin, divide natin both side by 2.024 para ang maiwan na lang ay si mass. So cancel na natin si calories since magkapareho sila. Then divide 57 by 2, and that is equal to 28.327060 and so on grams. And since the SI unit of our mass is in kilogram, convert natin si grams into kilogram. So 1 kilogram over 1,000 grams. So cancel yung grams. Then divide 28 by 1,000, and that is equal to 0.0028. So since the least number of significant figure is 2, so we will round this to 2 significant figure, and that is equal to 0.030 kilogram. And that is the mass of the object. The last effect of heat is the change of phase, which changes, okay, changes the state of matter, okay, from solid to liquid, or from liquid to gas, or gas to liquid, or vice versa. So if an object, okay, if an object reaches a certain temperature which absorbs heat or releases heat, then the intermolecular forces of attraction between molecules will be broken. So a heat is needed to break the intermolecular forces of attraction between molecules. So every molecules has an intermolecular forces which attracts two or more molecules, which is a result of the of forming a matter. And when the matter absorbs heat, okay, when a matter absorbs heat, then a certain heat energy is needed to break that intermolecular force of attraction. And And on the other hand, if an object releases enough heat, okay, if an object releases enough heat needed, then the intermolecular forces of attraction between molecules, okay, so it will improve, okay, so if an object releases enough heat, then it will improve the forces of attraction between molecules, okay. So um the change of phase, for example, let's have an ice. So an ice which has an initial temperature of 23 degrees Celsius. So that is the temperature of the ice when it is on the freezer. Okay, so assuming that is the temperature of the ice while it is on the freezer. So as the moment you will pull out the ice from the freezer, then place it outside the freezer, and it will be exposed to heat. The ice will absorb the heat energy, okay. The ice will absorb the heat energy from the heat that it is being exposed. So as it is exposed to the heat energy, it will absorb the heat energy that will uh, that will change or increase the temperature of the ice, okay. So dahan-dahang tataas yung kanyang temperature, and then as the moment it reaches the melting point of the ice, which is in Celsius, that is equal to 0 degrees Celsius. So as the moment its temperature reaches 0 degrees Celsius, then the intermolecular forces of attraction between the molecules of the ice, okay, it will break down those forces of attraction between the molecules of the ice, which results to to a change of phase, which is through melting. So through melting, mababago yung phase ng ice from solid state to liquid state. And during this process of changing of phase between the state of solid to liquid, during this process in the changing of state from solid to liquid, the temperature of the ice, okay, the temperature of the ice will pause for a while. So hindi mo na mag-i-increase yung kanyang, or hindi mo na mababago yung kanyang temperature while doing the process of melting. So habang nagme-melt yung ice, okay, while changing its phase from solid to liquid, so hindi mo na mababago yung kanyang temperature, but though the temperature doesn't change, but it will continuously absorb heat energy, okay, but it will continuously absorb heat energy. And since there is no change in temperature while changing the state of an ice to a liquid, so we cannot use the equation we used kanina, which is the H is equal to M times C times change in temperature. So hindi natin yung pwedeng magamit since there is no change in temperature in the state of changing the phase, or in the process of changing the phase of the matter. So sir, paano namin malalaman yung heat absorb or heat release ng object if it is undergoing the process of change of phase? So since sabi mo kanina na it will continuously absorbs heat energy, so paano namin malalaman kung ano ang value ng heat energy that it absorbs while doing or while undergoing the process of changing its state from solid to liquid? So to do that, okay, to do that, we will use the equation of the specific latent heat. Okay, we'll use the equation for the specific latent heat. But before we proceed with the equation of specific latent heat, alamin muna natin what are the two types of heat transfer. So what are the two types of heat transfer? So there are two types of heat transfer, the heat absorption and the releasing of heat. So absorbing heat and releasing heat. So what do we call this type of heat transfer? So when we say heat absorption or absorbing heat, then it is called as endothermic. And when the object is releasing heat, then that is what we call as exothermic. So endothermic, heat is being absorbed, and exothermic, heat is being released. So these are the two types of heat transfer. Okay, so these are the two types of heat transfer, the endothermic and the exothermic. So balik tayo dun sa specific latent heat which I mentioned kanina. So the specific latent heat, as I have said, ito yung gagamitin natin. So we will use specific latent heat to be able to identify the heat absorbed or heat released, okay, of the object while changing its state without changing its temperature. So while undergoing the process of changing its state or changing its phase, the object, okay, or the temperature of the object will not uh, change. So hindi magbabago yung kanyang temperature while undergoing the process of changing its state. But still, the object will continuously absorbing heat energy or releasing heat energy. So paano natin malalaman ang value ng heat energy it absorbs or the heat energy it released if we cannot use the equation that we discussed kanina? So to do that, we will use the equation for the specific latent heat. So the equation for specific latent heat, okay, is equal to M times L. So heat is equal to M times L, where H is the heat absorbed or heat release, M is the mass, and L is the specific latent heat of the substance. And the specific latent heat, okay, in the specific latent heat, we have two types of specific latent heat, okay? So there are two types of specific latent heat. So the first one, or the first type of specific latent heat, is the heat of vaporization, which consists of liquid gas relation. So when we say liquid gas relation, so it is changing of phase from liquid to gas through vaporization or gas to liquid through condensation. And the other type is the latent heat of fusion, which consists of a solid liquid relation. So when we say solid liquid, so changing of solid to liquid by melting and liquid to solid by freezing. So these are the two types of specific latent heat. So the vaporization and the fusion. So it is much better for us to be able to know the types of latent heat so that we can be able to identify or know what type of specific latent heat ang ating gagamitin. So for example, the object is undergoing a process of melting. So hindi pwede na ang gagamitin natin is vaporization since the object is undergoing the process of melting. So since it is melting, so ang gagamitin natin ay yung specific latent heat of fusion. So ito yung two types of specific latent heat. So we have fusion and vaporization. And to solve for those specific latent heat, we will use this equation. Okay? And these are their SI unit, which is in joule, mass is in kilogram, and specific latent heat, which is in joule per kilogram. So using this equation, we can be able to solve for the specific latent heat or the heat absorbed of the object while undergoing the process of changing its state. So let's try to use this in a given equation. Okay, so how much heat in kilojoules is needed to change the temperature of 50 grams of ice initially at negative 18.5 degrees Celsius to 30.0 degree Celsius? Okay, so if the specific latent heat of the ice is equal to 333.7 kilojoule per kilogram, and the specific heat is equal to 4.186 kilojoules per kilogram Kelvin. So hahanapin daw natin yung heat needed to raise the temperature from negative 18.5 to 30 degree Celsius. So sir, sabi mo kanina, sir, hindi mag-i-increase yung temperature ng object if it is undergoing the process of changing its state. Okay, yes, the temperature of the object will not increase if it is undergoing the process of changing its state. But that doesn't mean that the object or the temperature of the object will not increase. Okay? So the temperature of the object will increase, but as I have said, it will pause for a while as the moment it reaches its melting point. Okay? The moment it reaches its melting point, for example, in this case, in the ice, so the temperature of the object increase from negative 18.5 degrees Celsius, but it pauses for a while the moment it reaches its melting point, which is equal to 0 degree Celsius. So the moment it reaches 0 degrees Celsius, so the temperature will pause for a while, and then it undergo a process of changing its state from solid, which is an ice, into a liquid, which is the water. But since it continuously absorbs heat as it changes its state, so di natin pwede na directly solve for the heat absorbed of the ice from negative 18 to 30 degrees Celsius, just like what we did kanina. So ang gawin natin dito is first kailangan muna natin kunin yung heat absorbed or yung heat absorbed ng ice from its initial temperature, which is 18.5 degrees Celsius, up to the melting point, which is the 0 degree Celsius. So that is the first heat. Okay, so meron na tayong heat absorbed from 18 degrees Celsius to 0 degrees Celsius. Then after that, kunin na naman natin ang heat absorbed ng ice the moment it undergo the process of changing its state from solid to liquid using the specific latent heat. So after we solve for that heat absorbed, the next, since nag-continue pa rin sa pag-increase ang kanyang temperature up to 30 degrees Celsius, so solve na naman natin yung kanyang heat absorbed from its melting point, which is 0 degrees Celsius, up to its final temperature, which is 30 degree Celsius, using the specific heat, or yung M times C times delta T. So in short, we need to solve three heat absorbs, okay? Three heat absorbs, which is first, from negative 18 to 0 degree. Then second, the specific latent heat, which is the process of undergoing the change of state. Then third is the heat absorbs from its melting point up to its final temperature. Then after we solve for those three heat absorbs, we combine their value, or we sum up their value to be able to identify or to know the heat needed in kilojoules to change the temperature of the ice from negative 18 to 30 degree Celsius. So to do that, okay, so first, so let's solve the total heat needed. But first, gaya ng sabi ko, solve muna natin yung heat absorbed ng ice from its initial temperature, which is negative 18.5 degrees Celsius, up to its melting point, which is the 0 degree Celsius. So since there is a change in temperature, so ang gagamitin natin is a specific heat equation, which is mass times specific heat times the delta T. Okay? So mass times specific heat times the delta T. And since the unit of our specific heat is in kilojoule per kilogram and times Kelvin, and our mass, the mass of the ice, is in grams, and its temperature is in degrees Celsius, so convert muna natin sila para magkakapareho yung kanilang unit. So convert natin si 50 grams to kilogram. So cancel yung grams, and that is equal to 0.05 kilogram. Then next, convert natin ang ating temperature into Kelvin. So using Kelvin is equal to degrees Celsius plus 273.15. So its initial temperature is 18.5 plus 273.15, that is 254.65. Then the melting point, which is 0 degrees Celsius plus 273.15, that is 273.15. And then subtract natin silang dalawa, 273 minus 254, that is 18.5 Kelvin. And that is the change in temperature. So next, substitute. So cancel kilogram and cancel Kelvin, since magkakapareho lang. Then multiply, and that is equal to 3.87205 kilojoule. And that is the heat absorbed of the ice from its initial temperature, negative 18.5, up to the temperature of its melting point, which is 0 degree Celsius. And since it reaches the temperature of its melting point, then the temperature will pause for a while, and the ice will undergo a process of changing its state from solid to liquid. Okay? So since nag-change ang kanyang phase or yung kanyang state, and it continuously absorbs heat, so solve natin yung kanyang heat absorb using the specific latent heat. So since it undergo a process of melting, So ang gagamitin natin is yung fusion. So the specific latent heat of fusion, which is H, is equal to M times L, where M is mass and L is the latent heat of fusion, which is 333.7 kilojoule per kilogram. So substitute, cancel yung kilogram, then simplify, and that is equal to 16.685 kilojoule. And this is the heat absorbed of the ice as it undergo a process of changing its states from solid to liquid. Then after changing its state, since it continuously absorbs heat, then tumaas yung kanyang temperature up to 30 degree Celsius. So next, since nag-continue sa pagtaas yung kanyang temperature, so kunin natin yung kanyang heat absorbed during the increase of temperature after changing the state of the object. So using M times C times delta T, so same kanina, convert natin si grams into kilogram and Celsius into Kelvin. So 30 degrees Celsius convert to Kelvin is 303.15 Kelvin, and 0 convert to Kelvin, that is 273.15 Kelvin, and then subtract 303 minus 273, that is 30 Kelvin, and that is our change in temperature. Okay, next, substitute. So that is 0.05 kilogram times its specific heat, 4.186 times the change in temperature, which is 30 Kelvin. So cancel yung grams, kilograms, and yung Kelvin. So multiply, and that results to 6.279 kilojoules. Okay? So next, so since dyan lang natapos yung kanyang temperature, so dyan rin matatapos yung pag-solve natin ng kanyang heat absorbed. So since we have 3 heat absorbs, so we combine them, okay? We sum up the 3 heat absorbs to identify or to know the total heat absorbed. So just simply add them. So i-add nyo lang yung tatlo. Okay? So since magkakapareho yung kanilang unit, which is in kilojoules, so we can directly add. Pero pag magkakaiba yung kanilang unit, so convert muna natin sila para magkakapareho na yung kanilang unit. So since in this case, they have the same units, then we can proceed in our addition. And that results to 26.83605 kilojoules. And since the least number of significant figure is only 1, so we will round this to one significant figure, and that is equal to 30 kilojoules. And that is the heat needed to rise the temperature of the ice from negative 18 to 30 degree Celsius. So how much heat is needed to completely melt a 1.5 kilogram of lead initially at 20.0 degrees Celsius? So in this case, same kanina, nahanap natin is yung total heat needed. But this time, after the lead is being melted, hindi na nag-increase ang kanyang temperature from its melting point temperature. So kanina, since nag-increase pang kanyang temperature from its melting point, so that's why tatlo yung heat na ating solve. But this time, since it stopped increasing its temperature from its melting point, so dalawa lang yung ating isolve. So first is the heat absorbed from 20 degrees Celsius to its melting point, which is 327, and then the heat absorbed as it was changing its state from solid to liquid. So since magkakapareho rin yung kanilang unit, so kilogram, and degree Celsius, so no need na to convert any of them. Ang kunin na lang natin muna is the change in temperature. So from 327 degrees Celsius minus 20 degrees Celsius, which is the initial temperature, and that is 307 degrees Celsius. Then substitute, cancel yung kilogram and yung Celsius. Then multiply. So that is 246.828 joules. The next, so for the heat absorbed while changing its phase from solid to liquid using the specific latent heat of fusion. So substitute mass is equal to 1.5 and the latent heat, which is 22.9 joules. So cancel yung kilogram, then multiply, that is 34.35 joules. So since nag-stop na yung kanyang temperature after completely melted from solid to liquid, then ito lang yung ating heats. So after that, to be able to know our total heat, add lang natin si H sub 1 and H sub 2. So 246.828 plus 34.35. So since magkapareho yung kanilang unit, so pwede natin sila i-add diretso. So that is 281.178 joules. And since the least number is 2, so we will round this to 2 significant figure, and that is 280 joules. And that is the total heat needed to completely melt the lead from 20.0 degree Celsius.